Welcome, everybody. Today's Sendo Reliability webinar. This is Fred Schenkelberg, and we're going to dive into the quality world, which, well, I have some opinions about which is quality and which is reliability, or just good engineering, but I'll get to that in due course. So today, I this today's topic was inspired by a question I got about the need to train an organization on basic quality tools. And I thought, wow, that's not being taught anymore. I guess unless somebody's actually teaching it, it's not out there. Apparently, I started my engineering career in an organization that did a lot of training. It was nearly every month we were in some kind of formal class for everything from design of experiments to quality circles to continuous improvement and just about everything in between. And weeks and weeks of work on learning control charts, for example. And that was just one topic of the basic tools. So I didn't even think of it as the 7 basic quality tools. And I'm not exactly sure where that phrase got coined or why or whatever, but the more I looked into it, the more I found that there were different lists, and there were some commonalities, but mostly it was a mixture of 9 different tools. So we'll talk about 9, even though we commonly call it the 7 tools. But be that as it may, we'll go ahead and get started. I'll be using the chat window as much as we possibly can. And so feel free to throw in questions or comments or ideas or suggestions. And I'm going to be asking for some of your experience because I'm quite sure many of you are very familiar with these tools. And so maybe 1 or 2 of them will catch your attention. But I suspect with this audience, you're already pretty good at it. So we'll talk about it. Well, we'll see. Well, see how it goes here. Now, if I can get my cursor to advance the slides. There we go. All right. I have found with the Accendo Reliability website that looking at the analytics and what gets searched for and what gets viewed and where we get comments and things like that, it almost always is on the basics or the fundamentals. You know, how to construct a control chart, how to build a Weibull plot. The 7 steps to do something, the 10 steps to do this. It's and one theory that I heard over the years is that the fundamentals are, you know, they're alluded to, they're mentioned in a variety of books, they're talked about, and we know that they exist and there's ways to solve particular problems. Yet, unless you've been taught about these or made aware of these various tools, then you go look for them. And because it's, one person told me it was embarrassing to go ask your boss, well, what is a Pareto chart? How do I create one? When you could Google it or look it up and get some concrete advice and look like you already knew how to do it. And which is fine. I mean, I do that myself. I look up stuff just about every day. It's a great resource. But I think there's a balance of understanding the fundamentals and being able to implement them and build on them. And by doing so, we create a really solid foundation for what we do in problem solving or failure analysis or in data analysis or in just the way we approach a question or a problem. And it's from this solid foundation, using these foundational tools or these fundamental tools, it allows us to move into things like more advanced control chart processes or more advanced failure analysis techniques or more advanced statistical processes. But the idea is that you need this good solid base before you move into all of those things, and not just as an ad hoc tool here and there. The overall intent is that it's a continuous improvement process, and it's no right sequence of use of these tools. It's knowing them well enough that you use them as appropriate for the particular circumstance you're in. And the better you get with these tools, the more versatile they become, more handy they become. I often look at it and I'm kind of, I think of it as it's a toolbox, right? And these are the screwdrivers and hammers. These are and pliers. These are the basic stuff that's pretty much in a beginner kit and in advanced kits and toolboxes all around the industry have these fundamentals in them. And so that, I realize I haven't listed those tools yet, but we'll get into it here in a minute. Now, some of you may be wondering why I'm talking about quality tools. And some of you, I know that Long Chun and a few others have been to many of these webinars, know my opinion on this, is if you ask a quality engineer or quality manager, what's the relationship, they will say that reliability is one of the aspects of quality. And so quality has, like, I think it's 14 or so characteristics or aspects, and reliability is just one of those. It's a subset of quality. And as many of you know, I think the reverse is true. We got to do everything that quality does, but over time. We need to understand the customer's expectations. And if the expectation is it's the wrong color and they return it immediately, I consider that a reliability problem because it hits the warranty accruals. It costs us money to field a phone call or to replace a product, or when we lose a customer. And on and on and on. I can talk about each of the qualities of quality or each of the aspects of quality, and it is a reliability issue. So I think of quality as, well, they do what they do, and then we just do all of that over time. And so that's how I think of it. Yet at the end of the day, it doesn't really matter what title you have, whether it's mechanical engineer or design engineer or reliability engineer. We need to be able to solve problems. And that's what we do as engineers, is we face a dilemma or a problem or a failure or some functionality we want to improve upon. And we use a range of different methods in order to do that. And some of the most fundamental ones, these 7 basic tools, is a good place to start in most circumstances. It really is. It's jumping into a high-end design of experiments when you don't really understand the problem is usually not a good start. So let's understand the problem first and then move on to that. But anyway, I talk about quality because, and quality related tools or things that are typically bucketed in quality training, because they help us be a better reliability engineer. They help us solve problems, and they're not exclusively in the domain of quality. We certainly can dip into those, and we should. All right, so I've mentioned that I've identified 9 of these 7 basic tools. And as I was looking at preparing for today's presentation, I realized they kind of fell into a couple different groups. And the first ones we're looking at processes. And it's a good way to take a look at what the tools are really good at or what they do. And one of the most fundamental, basic, simple tools that's out there is a check sheet. Now, it's not glamorous. It can be misused dramatically, right? It's one of those things that, and matter of fact, later today, I'll be heading to the airport for first time in a couple of years. And I really hope the pilot and co-pilot go through a pre-flight checklist, right? And the idea is that even with very well trained and educated and experienced people, for when you really don't want to miss something, a check sheet or a checklist is a way to make sure that happens. So it has a really good value proposition for such a simple item. Now, the list that's on here is roughly what I do each time I go through preparing for a webinar, create a title, set it up and advertise and so on. And later today, I need to figure out how to get the recording posted. Now, that's pretty high level. Yet, if you make a checklist that had every single excruciating step in there, then it's still a checklist, but is it meeting that audience's need? So for me, these 6 different things give me the basic flow and the items I need to do, and I could add timeline or lead time or things like that to this list. But the checklist needs to be created to outline a process or to define a process, but appropriate for the audience that you're dealing with. Who's going to use this, and what cues or reminders or steps do they need out detailed for them? And that's where they become very, very useful, is when they match the person that's using the list so that it is useful for them. It adds value to what they're trying to do. It reduces the chance of making mistakes. And so if you make it too detailed, it's onerous to use. If you make it too basic or too high level or inappropriate, where it says set up Zoom, and if I've never used Zoom before, I wouldn't know how to really do that. I'd have to go sort that out. So it has to be tailored, and it has to evolve as the process that you're using changes, or as things update or evolve. Like when we moved from GoToMeeting to Zoom last year, then the basic steps that I took changed. And so the checklist is a way for, especially for linear processes, to create a reminder and a touchstone so that you minimize errors if they're used well. Now, another one is flowcharts. And I'm quite sure many of you have seen flowcharts or created flowcharts and so on. And they're essentially a graphical checklist in many regards. They may be used for, say, an assembly process that has a couple different steps, as a starting point where we get all the materials together and we feed it into a machine, and then we have to make a decision. Is it product A or is it product B? Well, if it's product A, we got a couple extra steps. In product B, there's one more step and we're done. But the idea is that it allows us to include decision points. And I'm sure you've seen all the various different types of boxes that you can draw, little database cylinders for an archaic old memory system that says, well, here's storage or memory or retaining it. We use cute little symbols for reports or output. But the basic blocks are rectangular or square, and they give you a title or a checklist-like statement that has appropriate amount of detail. And then the diamonds for decisions. And they don't have to have only 2 outputs. They could be a 3-way decision, or however many is appropriate for your particular process. And then the arrows show the flow of a manufacturing process, the flow of materials. Or it could be say a financial transaction process, and it would be the flow of information and so on. So the flowcharts add a level of complexity, or the ability to model or draw or diagram a bit more complex process, one where there's decision points or breaks or points of change or so on. So they're very related to the checklist, but they're graphical, generally in nature rather than a list, and they can handle a bit more complex type stuff. Again, very, very basic stuff. Both of these I'm sure you're familiar with. But the idea is that just like checklists, flowcharts need to actually help you understand a particular process. And years ago, I was working with a team that we would wait about a week from the time an electrical circuit was designed to we had prototypes. And we used basically a flowchart to understand the flow of information, the flow of money and approvals, the flow of the ordering process. And there was like 4 or 5 other elements that went into going from on Tuesday, the design is ready to be built, to the week later, Tuesday, we actually build it. And so we outlined all of the steps and laid it out in our big flow chart. And we found that there was this one bottleneck where the person in the procurement steps of the process, they had to have final approval of what was exactly going to be purchased for that prototype. And they would wait until the designer was done, because before that, there was some ambiguity, if I pronounce that right. We might be ordering say 500 different components, but 6 or 7 of them had a couple of options. The designer wasn't quite done yet. And so we made the proposal that the procurement organization buy all the parts 2 weeks prior, before the design was done. And the argument was, well, it's going to cost us $40 if extra, if we buy parts we know we're not going to use, right? So that was kind of the bottleneck, the hold. That was the key part, because once they figured out what all the final components were, then they made purchases, and it took upwards to a week to receive all of those components. So that was discovered just by laying out a flow chart of where all the issues were, or where all the steps were to go from design to prototype. And so we made a proposal saying, if we spend an extra couple $100 to buy a few components that we're not going to need early, knowing that we're not going to use them, it will cost us, at most $1,000. But we get 4 or 5 days back in the development time, where the designers get their prototypes and they can start debugging and testing and evaluating them. We would have more time back into the schedule. And so the program manager was ecstatic. That was invaluable to them. And she was estimating it was upwards to $500,000 to $1 million a day, while we're doing work that, yeah, it still kind of needed to be done, but the most important thing that was to be done was to evaluate these prototypes. And so getting them quicker meant saving on the order of millions of dollars. And so it was an easy proposal to make, to buy components earlier, even though we knew some weren't going to be used. And that was one of the best values I got out of just doing a really simple flow chart, although the process itself was pretty complicated. This diagram I got here doesn't quite cover it. And one more that's, I'm sure you're familiar with, is control charts. Now, I was surprised that I found control charts on the basic quality tools. It's control charts, in using them well, is not simple, except when the team itself knows how to use a control chart. You really do need to know what you're doing and how to use it, and how to use it well, how to interpret it. I've seen way too many control charts that are behind glass and updated once a month, that are pure figments of imagination, or if there is real data behind it, nobody's actually using that data to do anything. This chart on first glance looks like it's under control. It's in control, or stable, as we would call it. A little more analysis might reveal, certain triggers that would signal that there's some out of control circumstance. But the basic idea of these things is what I think makes it a basic tool, because we know very, very little about a process if we don't know if it's stable, right? And that's the fundamental basic of control charts, and why I think it's a basic tool, is that it really does. Westinghouse rules apply, definitely, Robert. And I think there's even a handful of other rules out there for the more exotic statisticians in the world, but the basic Westinghouse rules, I think there's 6 or 7, something like that, that most people recognize, count perfectly well. And that's perfectly fine. And the I have a copy of that book on my table. It's from Westinghouse Electric back in the 30s, I think, or 20s or 30s, and it outlines doing control charts. So it's 100-year-old technology or process or technique. The fundamental part of it, though, is that we're really lost in looking at a process and trying to make improvements or making suggestions for how to change it, or is it adequate or not? Is it capable or not? All rely on that we monitor elements of that process such that we can define that it's stable, that it's consistent from one product to the next product, that we're going to get an output that's not chaotic and random. Now, it's a different question whether it's in spec or not. That's beyond control charts, for most control charts anyway. But the idea of the concept is that it's a tool to determine if a process is consistent, I think is the basic part of it. Now, there are lots of different kinds of control charts. And the art of doing control chart is measuring the appropriate thing and making sure your measurement system is good and all those kinds of things. So those are three basic tools that deal with processes, at least the way I've seen them used and interpret them. So what are some of the ways that you've used it? I told one quick story there about using it to shorten a prototype period with a flow chart. What about checklists? The airline pilots use them, but who else has gotten some benefit or value out of that? And what about control charts? Are you using them? That's probably, or know of your manufacturers, and are they using them well? So go ahead over to the chat window if there's any questions or stuff. And it gives me a chance to get a sip of water. I don't think that's actually a very good question, is it? What are some uses that you use? What are some of the ways you use these tools? Would probably be more grammatically correct. Maintenance routines. Excellent, Brian. Yeah. Yeah, and Robert, you're right. Once you go through the checklist, a dozen or 20 times, I'm that way with recipes. But each time I ignore the recipe, I come up with something different. Now, in cooking dinner for my wife and I, that's not necessarily a bad thing. The hard part comes when it's something that turns out really, really well, and I don't really remember what we did. I have the recipe, but I know I didn't do that. And then I can't repeat it. There's a handful of times when having a pretty good checklist of what that process was comes in handy, even for something as simple as cooking. Yeah, bringing on new people. The onboarding system, I've heard, is a good way to do it. Yeah, it's a cultural thing. Do I rely on the checklist, or am I an artist and I do it whatever way feels right? The hard part is to encourage the use of checklists in a way that is beneficial to all concerned. And in some cases, the failure analysis part or the troubleshooting part, there are some guidelines and checklist type things if you do an 8D process, but there's plenty of room for creativity in it. But if I'm lubricating a Jeep, for example, I want to make sure I find and lube every one of the fittings, which I didn't do when I was in the Army for a couple of months and had consequences because I didn't use the checklist. It wasn't clear enough to me. It just said lube all points, and I didn't know how many points there were. So I looked under the Jeep and lubed as many as I could. But it was a cleaner checklist for me would work. Now, if I had more experience or better training, I would know this stuff, and then it would have been appropriate. Yeah, no, it looks like a bunch of checklist type stuff. And it's such a fundamental tool that sometimes we don't even know we're using it, but it certainly is there. Good. All right. So let's look at some of the ways we look at data. Histogram. Now, I wrote an article a couple weeks ago on how do you create a histogram, and I used Excel, R, Mathematica. I think I used one or two other packages, the ones I had available to create a histogram, and they were all dramatically different. One of the things about histograms that I found is that the bin size, the width of the bins, for variable data makes a big difference. Um, and there's some guidelines and rules when you have a lot of data, what's the appropriate bin size to use. Categorical data is easy. You know, if it's red, blue, green, orange, whatever, then I can just put them on there. I'm not sure if that's considered a histogram or not. I imagine it is. We can do categorical data, we can use ordered data, we can use variables data. Histograms are so versatile. But the issue I run into with histograms is that it takes 2, 3, 4 tries at different bin sizes to see what the data is trying to tell you. Or am I just hunting for something that looks interesting and then use that one? And I never really know. So I'll start with defaults. And this quick experiment I did with this article was the defaults for Excel, for R, and for Mathematica were all different. Same exact set of data, but completely different looking histograms at the end of the day. So it's a versatile tool. It's often where I start when I'm presented with a stack of data and I just want to get a hands on it or a visual of what's going on with it. How is it spread? Where's the mean? Where's the median? You know, I get a quick look at the data, is visualizing it. Histogram is often a first step. The trouble is that to really understand the data, you got to be careful in how you set up and interpret what you're seeing. Because if I change the bin size instead of 1 and 2, then 3 and 4, and like steps of 2 in this particular set, I could really change. If I did groups of 3, it would be a very different looking histogram. Now, of course, if you have tons of data, it becomes less and less relevant. Yeah, and Robert, using them to look for skew or outliers or clerical errors, all kinds of stuff. It has an amazing array of value for all kinds of reasons. But it's not the end of the story oftentimes with what's in that data set. And I find that trying a couple different bin sizes gives me different perspectives of the data set. And there are, common good practices and so on, but just doing the default and getting a quick look is the starting point. It's not the end of the story when it comes to histograms. Yeah, overlay the spec limits, good one. I like that because histograms are in the same units of what you're trying to do. Let's see, so missed a comment on control charts. Oh, good. Yeah, using it within testing and stuff. Yeah, Max, I've seen it used where the control chart was tied to the measurement system. And we were using it in a variety of testing on different tests, but it was more monitoring, is our test method increasing the amount of measurement error? And that was a creative use of control charts. So let's see, what else do I have in data? Run charts. I never really separated run charts from scatter diagrams, scatter charts, which is coming next. And I'm still struggling with what's a clean separation of these things. I think the run charts are typically defined as a one variable plotted over time. And so items coming off the end of the production line and get measured for some variable or some value of them, pass or fail even. You could put it on a run chart. They're kind of like control charts, except we don't have all the fancy control limits and we're not averaging or anything else on that. And so this particular plot, which is a little faded in the screen I have, is showing water use. And this is over a 5-year period. And this is my house, 1, 2, 3. And you'll notice, let's see if I can get my cursor up here. Oops. Oh, here, let's see, there's a way to do annotation. So you notice that there's a spike here, oops, which was, I don't know, a few months or about 4 years ago, and another spike and another spike and another spike. So this is just monthly meter readings every first of the month, which isn't perfect by any means because month lengths vary. I went off and measured how much water we're using. And if you recognize this, it looks like it's fairly consistent for the first couple of years. And then this spike was, if we didn't know any better, the question might be, well, was there a leak or some problem like that? Well, it turns out I put in a garden. We started doing a lot of landscaping. So we started watering stuff. And so these are from like June to September timeframe for each of these spikes. And that's because we're putting water out on the landscaping and on the vegetables and so on. And so it gives us if I didn't know that, I was just looking at water patterns or looking at this data set for the first time, a simple run chart says, there's something going on here on a cyclic basis, or that if I only had the first 2 years of data, it's kind of pretty consistent. We're using more than, say, 1 unit, but then up to 5 units roughly on a pretty consistent basis. But something changed, and that's just simply plotting your data, if it is relevant to plot it in a time basis, it gives you an idea of, is there patterns, or is there cycles, where's most of the data lie, all those kinds of things. This chart and the histogram give you different views of the exact same data set and give you different insights of what's going on. Now, histogram doesn't reveal I'm drawing a blank, the time-related aspect of how the data is presenting itself, where a run chart does. And vice versa, this doesn't give us really good evidence of what's the spread, what's the average usage, stuff like that. There's some rough ways you can estimate that, but the histogram gives you a better idea of what's the skew or outliers, things like that. Now, if I had only up to, say, 30 months, I would look at this one as an outlier. But looking at it on a run chart, it's like, there's a pattern there. And that's informative. So that's one aspect of it. Now, I'm not sure. Let's see, I can go clear. There we go. I'm not sure how to get rid of this thing. There we go. There's a big X here. Get my cursor in the right spot. That always helps. All right. So that's a run chart. Yeah. Toolware, great way to look at it. I found Toolware that really relies on having a good measurement system. I've learned that the hard way a couple of times. Now, a scatter diagram, and I think in some software packages, they call this an XY plot or something like that. It's another one of those easy ways to take a look at a data set. And then this particular diagram was from Wikipedia, and it's plotting 2 sets of data that were randomly generated from the same distribution. And so this is a random pattern. Now, if I'm doing a data set and I've got, say, temperature versus voltage, and I get this kind of pattern, I would probably conclude with this much data set that there's no relationship between temperature and voltage. Now, if I saw a nice straight line going from the lower left corner to the upper right corner, then I would say there's probably a definite relationship there. And I would expect that if I was measuring a thermocouple to see how it varied from temperature to its voltage output. Or I might see a funnel where it's very tight at the start and gets really wide later on. That's a different pattern on it. And so scatter diagram doesn't, it could do time based as one variable and the other variable, whatever you're measuring, but we probably should call that a run chart. Scatter diagram allows us to compare two variables. If I turn this knob, what does the temperature change to? Even though there's cause and effect there, sometimes we're just looking for relationships. We don't know if there is a relationship, say, between temperature and voltage. In a scatter diagram is a way to sense, is there a relationship there or not? Yeah, it can be looking for correlation, as you're saying there, Robert. It also can be looking for, do we have all the variables? So the patterns that increase in variability from one end to the next, maybe along a slanted line, suggests that there's something else causing more variability as I get into the further to the right on the diagram. So it gives us yet another view of a little bit more complex type of data. Now, if you get really fancy, you can do multi-dimensional ones. You can have 3-dimensional scatter diagrams and 4 and 5 and 6. Although you can only see 3 variables at a time. But R and some other software packages allow you to do scatter diagrams with many, many variables. And you take different views, different filters to look through into that space. If you come up with a 4-dimensional way, or 4 or 5th dimensional graphic, that'd be cool. I'm not exactly sure how we would do that, but that might be worth a few dollars. But anyway, these are 3 basic ways of looking at data that we all typically use. The hard part that people run into is they stop at just the histogram in their first look at it, or they stop with just the run chart and then don't ask any questions and use it well, and try to figure out, well, what's going on here? What's happening? I saw one where it was a run chart that was showing it was a 5-year cycle of children entering grade schools in this town. And it was slowly increasing as an overall time series, but it had a cyclic pattern and it varied about 10% around that center line that was improving. And so I saw a presentation to the board of directors where the analysts took the last 3 years of data, which were showing a market upswing, just that upper part of that typical pattern that was happening. Now, let me draw this. This is one of the worst uses of a diagram I've ever seen. Like this. So they had time, and then it was enrollments on the vertical axis here. And it was kind of doing this and just slightly increasing. And so what the analysts did is took these 3 points and extrapolated a straight line off of that, saying in 2 years, we're going to have twice as many schools are going to need to be built. And luckily, the board of directors and everybody involved was looking at the larger pattern and going, we have some pressure to build a new school, but not for a while. But I didn't ever gather why this person picked only the last 3 years of data. Maybe they had stock in the building departments or something. I don't know. The different ways of using diagrams is a way to uncover what's going on in the data set, to help us answer questions, to see patterns, and to understand what the data set is other than just a table of numbers. And so using a range of different charts and diagrams and plots helps us to get different views of the data. And that's why these are basic tools, is they allow us to get started with our analysis. They're by no means the end of our analysis. And each of these types of things can have curves fit on them, like a distribution on a histogram, or run charts or scatter diagrams can have regression analysis done on them. But generally, the starting point is just plot it. Just look at your data. And so that's it. a key takeaway for this one. Let's see if I can get my cursor back. There we go. With these kinds of plots, what have you seen? Right? What kind of uses have you used for these things? And on the histogram, a couple of folks are already talking about looking for skewness, or where's the center, where's the bulk of the data, how does it compare to specifications? Are you running experiments where a run chart or a control chart, or not a control chart, a run chart or a scatter diagram are helpful or useful? Well, I'm going to dive right in. If you've got some ideas or comments, go ahead and add them in. Let me see if I haven't scrolled there. Yeah, CPK. Yeah. And that's an advanced tool compared to these ones, but you use a control chart to get that started. Histograms also allow you to visualize that to somebody, saying, hey, this is where the actual data is versus our spec limit. That's good. Now, invariably, we have failures. Something goes wrong with a prototype, or in a design's not quite working. That's considered a failure, and we need to figure out why it's not working as expected, or we have field failures. Or a piece of equipment goes down. We have all kinds of things that sometimes take just start thinking about, well, what's going wrong? Well, the Pareto chart is a way to take a look at what's going on. And it's a common tool. I've seen it used in all kinds of industries and all kinds of circumstances. And one of the things that seems to bear out over and over and over again is this basic idea of the Pareto principle, that 80% of the faults or issues or problems that you're seeing, or items or counts or whatever we're doing, is typically within 20% of the components, say, or subsystems, like in this particular one. And then there's a few vital few areas that have the most problems, and then the other ones tend to drift off to being insignificant compared to them. Now, if we solve the CPU and the hard drive issues, then power supply and keyboard would take up 80% of the issues. It's always relative to how many issues you're looking at. And that basic process, for whatever reason, I don't know how Pareto discovered it, but the idea is it's been replicated and seen in so many different industries. Now, when we're looking at field data, or we're looking at types of problems that we're running into, a Pareto chart is a great way to just get a good start on this. What are the big issues? Now, of course, there's modifications to these, because if the issue is not expensive or the customer really doesn't care, it might be a big issue, but it's not significant because it doesn't cost the customer or us a whole lot of money. So you could weight it by the cost per failure, for example, and use it to a slightly different way. Basically, still a Pareto chart, but instead of just using cumulative counts, we're using a weighted count, for example. The one that, and I see it way too often, and I'm sure you've run into it, is you do a Pareto of field failures, and either number 1 or 2 is no trouble found, or no fault found, or some variation of that. And then there's every now and then somebody says, that's a big hitter there, we need to solve that one. And then we take apart all of the, more detailed analysis on the no fault found, and create another Pareto chart, if we can. The hard part here is, well, what's the scope? Are we just counting how many CPU boards came back with faults? Well, the CPU board may have 1,000 components on it and could fail for 10,000 different ways. What's the Pareto of just the CPU problems? Because it's not just fix the CPU. That's not really helpful. And that's the point of this basic chart, is to help you provide, well, where's the opportunity? Where's the focus? Yet it's just the start. there's probably another level of detail of analysis you need to do, and it might be another rescoping of your Pareto chart to get into it. Yeah, sorted bar chart. And I was surprised that Pareto was considered a basic chart as opposed to the bar chart, which also has lots of different uses and it's a fundamental thing to use. But I think histogram is a type of bar chart in many packages. I think it's a building tool for Paretos and histograms, and a sorted bar chart is great. Yet it's amazing to me how informative these things can be. And this is just a default, I think, in R, creating a Pareto chart. And it does a reasonable job. You don't need three-dimensional ones. It makes it hard to make comparisons. You could put numbers on it. You could put a graphic on it. You could do all kinds of different things with it. But the idea is that it provides a glimpse of, in this case, count data that's hard to get your mind around in other methods. Plus, it builds on this concept of the Pareto principle, where it's the 80-20 rule kind of thing. So it's a pretty handy little chart to have ready to go. Now, when I saw stratification listed as a basic tool, one, I had to go look up the word, because I know what, adding layers to stop something was. Stratification is like a geology type term, is where I first was thinking, what does this got to do with it? But then I a little bit of reading about it and refreshing my own memory, I don't think I've ever been taught that it's called stratification. But when, let's say there's an issue on the production floor, and these 25 samples taken from the day's production were faulty. They're scrap. We have to throw them away or repair them or do something like that with them. And that's unusual. Let's say that's unusual for a typical day's production. A common question is, was it from one line? Or was it during one shift? Or was it from one machine? Or was it from one batch of material? Or was it from one vendor's source of material? What lot were they in? Is this before or after a particular change or repair on that production line? And all of those kinds of questions that we ask about some novel new set of data, especially around failures, is, well, what's the scope? How big is this issue? Is this affecting all production and we just now detected it? Or is it affecting only 25 units that we happen to catch? Or is it a signal that today's production was different in a significant way than otherwise, and why is that? And so it's a common technique to step through, and divide and conquer is probably the way I was taught it. One is scoping. Do we need to shut down the factory and do a recall? How big is this problem? Or what are the potential sources of the cause of this problem? And so Robert, I know of Shane and Shane in engineering, but does he use the word stratification? Because I probably learned the concept there, but didn't, with the 4-syllable, 5-syllable word, I probably didn't remember the word. He uses split the dictionary. Yeah, the same basic concept though, is the idea is that break down the problem so that you can do an experiment. You can measure something and say, no, it was isolated just to one batch and other batches are fine. And that helps us parse out where the potential underlying causes could be. It's a technique to get a handle on a problem in a useful way. Now, I know that Shane and others teach that there's methodologies to do this and ways to get to it. I found maybe it's just because I've seen it for so long and done it for so long that it's just intuitive. but typically it's start big, with the big groupings and then refine it as you narrow it down. The problem is that you might find yourself down a rabbit hole that has nothing to do with it if you made a mistake or two along the way. Yeah, and it's stratification, and I agree with you, Robert, is this tool, like all these other ones, is part of on other processes. It's built into so many other techniques and processes that, this one I'm saying is typically used in failure analysis, but it could be used in lots of other areas of what we do in quality and reliability. And let's see, I got one more tool here. And I couldn't spell Ishikawa. I probably could look it up, but it's also a name for it. Or fishbone diagram is yet another name for it. This one wins the prize of having the most names for whatever reason. It's a way to organize a brainstorm, is probably where I've seen it most often. You could use it proactively in a design deal, saying, well, how do we get this computer to work? What are all the elements we need to make sure it works? We could organize our thought process. It's different than a mind map or different than a flow chart. It's just another way to break things out into different groups. Now, in failure analysis, I've often seen it used with the 4 M's or the 6 M's, or here I noted that, some people use the environment or the outdoor the stresses around your product. Some will use Mother Nature so that they get the M there. But those would be the categories. Cat 1, Cat 2 might be materials and measurement. And then off of that, you put smaller bones saying, well, what's relevant to causing this problem that we're seeing, or this issue we're seeing, or target we're trying to solve. And then it just allows you to branch and organize thinking and hopefully spark additional thought and ideas of what could be causing the problem. Now, it's not the same as a fault tree diagram, right? If I turn this so it's the little categories or underneath the problem statement, it's not exactly the same. It could be a starting point to organizing a fault tree. But it's one of those tools where there's some problem or failure or something, like the computer won't turn on. And I look at materials. Well, is something shorted? Is something not dielectric that it used to be dielectric? Did a solder joint fail and come loose or something like that? Is there a measurement problem within the device that's saying, hey, we don't have power, when there actually is? Maybe there's some. It allows the organizing and sparking of ideas in different groups. Now, this is similar to what I see in really well facilitated brainstorm sessions, where the facilitator says, all right, what about materials could fill in the blank for your brainstorm? And now you're anchored. It's the idea of anchoring. You say, all right, now we're thinking about materials, and then sparks ideas. Now we're thinking about people, and how do people interact with the system? And that anchors the brainstorming activity. Doesn't limit it, but it anchors it. It says, here's an area to start your thinking. So instead of thinking about all 6 of these different vectors at the same time, you can isolate separate categories of it in order to help people to broaden their ability to think of all the different potentials that are going on here. So it's got a pretty good use, especially with complex problems, right? And if there's multiple ways and multiple elements of something going on, it's a way of just organizing that thinking. And so it's, whatever you call this process, it is pretty darn handy. And I've seen it used to better or lesser degree with various teams, often depending on the facilitator's skill of whether they pull one of these tools out of the bag or not, and make it work. So those are the 3 I've got related to failure analysis in general. Right. So how often do you use these things? This is I don't know, I'm trying to drawn a blank on what three I had. It was a cause and effect diagram, Pareto chart. I'll go back. Stratification. See, I don't even remember that word. It's a blank to me. So, and part of, I mean, I'm seeing it in the comments, is that these tools are common. We see them and use them in a routine basis. The real question is, are you building on these? If you see a time series pattern in a run chart, are you pulling out the time series regression analysis tools in order to fully understand it? Or is the basic run chart give you enough information like it did with my water usage? I didn't need anything fancy. I don't need to predict it or anything else, but I could see the pattern. I can explain the pattern. If I let my garden wither this summer because of the water shortage, then I suspect my water usage would go down, wouldn't it? Well, that's a good way to think of it, Max. Which one's used most often? Yeah, and I agree. Stratification is pretty darn common, to the point where I don't even think of it as a separate, distinct tool. It's just a thought process. But I think that's what makes these basic tools so fundamental, is that they really should be just ingrained within the culture. I remember being trained on brainstorming back in the 80s. I don't, now it's such a common tool and so widespread that we don't even consider it a tool. It's just what we do. We're going to do a brainstorm. Now, some are better than others, depending on who's involved with it. And there are other tools that could probably be listed in a setup like this, but these are the ones that I see that most commonly done. Pareto, histogram, Ishikawa. There's the spelling. I'm sure it's a capital I. And it's really it's a toolbox. I think that's the best analogy whatsoever. And there are screwdrivers, spanners, or wrenches, I think are two common terms for that same tool, and hammers. I mean, they're the basic setup of what we're doing. And they can be used together or in sequence. They can spring us off into more advanced tools. They can help us understand the world around us in ways that without these tools, we would probably struggle a bit. And so they've become so common because they're so useful. And that's the key takeaway here. So I think I've got a couple minutes left. Running a little quicker on this one. I didn't want to go into how to create all these things because I think that's what the articles are about. Oh, I should mention I've written 7 of the 9 tools have their own blog post on it. And when I get the other 2 finished, I'll put up an article that lists where all the other links are. And so it has one comprehensive grouping there. And I'll link back to this webinar also. But it's one of those things that I find that I did the histogram one, and I've written about histograms 2-3 times. They continue to rank really well. Lots of people go look at those things, which is great. I'm glad it's helpful and people find the information and use it and share it. That's all great. The real benefit is in the use of these things. And it comes from practice. It comes from somebody mentoring you or showing you, this is how to interpret this. This is what it means. But it comes with practice and experience that we get really good at these things. And they become just part of the muscle. They just become what we do, the mindset kind of thing, or the way we think. The more we can do that and build out from that onto the intermediate or advanced tools, all the stronger we get at solving quality problems or reliability problems. So let me shift gears here for a second. Next week, we have a Q&A session, same time, 9 o'clock Pacific time. We've had a few people join each of the sessions so far, so we have interesting conversations. People have brought some interesting questions, and luckily, a handful of folks have joined them that actually have really good solutions and answers to questions. It's certainly ones that I certainly could comment on, but I'm not the expert in a lot of these things. So the more the merrier at those sessions. We'll see you next week at that. A month from now, I just posted the webinar for next month, which is going to be on deliberate reliability testing. So, this is probably the first time in 5 years that I remembered what my next topic was. Chris Jackson's talking about, it wasn't apportionment. Well, I did forget what his is. His is in 2 weeks at 8 o'clock Pacific time on Tuesday in 2 weeks. And he usually has his beautiful animation and slides and great information that he provides. So I look forward to that. I'm drawing a complete blank of what his topic was. But anyway, I want to say thanks for participating. And one last note is that we updated, any of you that visited the site recently may have noticed subtle changes to it. And maybe some things not working as they should. We updated to a new platform within WordPress. We upgraded our WordPress backbone behind the site. And a few things broke, like the email system and formatting for it. And a few of the links didn't go where they were supposed to go. And we're still finding issues or problems here and there. So if you do visit the site and notice anything out of the ordinary or is not working as you expected it to, please let me know, because we're trying to troubleshoot the upgrade, I'm using air quotes here, until we start adding the features that are promised to be available in the upgrade. And we're already starting to use some of those, but we got to make sure the platform's stable and useful, not broken, before we move forward. So with your help, that would be great. All right. Let's see, I'm going to catch up with notes here real quick. Yeah, it's true. Most people can recognize patterns or pull concepts out of these basic tools. That might have been part of why they're used. They do add a bit of clarity in ways that just a stack of data doesn't, for example, or just staring at a problem statement doesn't. It allows us to piece it apart and solve things. So they are inherently valuable. And that's, I think, what makes them very, very useful basic tools. And it gets us started on making improvements or solving problems. And that's all good. All right, well, I'm up against the hour, and I'm going to say thanks once again for joining and participating. I really appreciate that. And I'll look forward to chatting with you all live, just a Q&A session or discussion group kind of thing next week, and then on a webinar next month. And with that, have a great rest of your Tuesday.